So we're going to solve this question for the BECE candidates. If you are also in JHS1 or JHS2, the question is for you because very soon you also write your BECE. So now let's answer this question right now. Given that 6 times the bracket of 5 plus 3 root 2 minus 6 times 5 minus 3 root 2 is equal to p root 2. We have to find the value of p. The I have to find the factors of p, and I the sum of the factors of p. So let's get that one here. That's going to be 1ai. So that is 1ai. So that's going to be 6 times bracket of 5 plus 3 root 2 minus, let me shift this one here, minus 6 times the bracket of 5 minus 3 root 2, and that is equal to p root 2. So that expression or the equation. So this is a statistical equation, an equation involving sets. Now let's move on. We are going to expand to remove the bracket. So as you all know, we are going to use the distributive property. So I'll just take 6 or multiply by 5. I also multiply the 6 by 3 root 2. So that's what I'm going to do. So let's start that one here, or let's do that one here. So 6 by 5 is going to be 30. So you have 30 here, and 6 times 3 root 2. This is how we're going to do this one. We just have to multiply 6 by 3. It's like, let's assume this one. Assuming you're multiplying 6 by, let's say, 3x. There's no way you multiply the 6 by the x. You're just going to multiply by 3, right? Because those are the numbers. So 6 by 3, that's going to be, 18. Then you attach the x. Whenever you are solving sets, use that idea. Don't temper the sets when it comes to, multiplication. Just multiply the coefficients. Maintain the radical sign, and that will be, very, very simple for you. So let me do that one here. 6 by 5 is 30. So let's multiply. 6 by 3 is going to be 18. Remember, it's going to be plus. We have plus. So we have 18. And now root 2. Let's move on to the next one. This is minus 6. That is minus 6 times 5. So that's going to be minus 30. And now minus 6 times negative 3 root 2. So negative 6 times negative 3. That's going to be positive 18. Remember that we have the radical sign there. Let me get the 8 well. We have the radical sign, that's the root of 2. So we're going to get 18 root 2. Now, everything is equal to p root 2 according to the equation. Okay. So at this point, we can group like terms. Let's say this one, 30, and that of this, they are like terms. So we are going to get, this 30 is going to be here. So we have 30. This is minus, so minus 30. We come to these ones, and that of this. So we're going to get plus 18 root 2 plus another 18 root 2, and that is equal to p root 2. So that is it. And we know that 30 minus 30 is going to be 0. So this one will erase this one. So we have 18 root 2 plus 18 root 2. And according to the law for addition of vectors, sets, let me show you something here. Assuming we have, let's say, a root b plus, c root b. How do we add these two? We just add the coefficients, then we take one of the, the radicand, or the radicand with the radicand. So that's going to be a plus c, now root b. So that's what you're supposed to know. So in this case, I'm going to add 18 to that of 18, and I'll take one of the, the radical sign with the radicand. So that's going to be 18 plus 18. Now, root 2. So 18 plus 18 is going to be 36. Remember, everything is equal to the root of 2. So you have 36 root 2 equal to p root 2. So here we do comparison. So I'm going to compare. So we compare. Now, when we say equal to, it means this side is the same as this side. You have to know the meaning of the equal sign. I've been saying that the equal sign doesn't give an answer, but it shows that the side is equal to this side. It's the same as this side. So if this side is the same as this side, then everything that we have here should be the same as this one. But when you compare, you can see that we have the root of 2 here. We have also the root of 2 here. This is P, but here is 36. So it means that P is the same as what? 36. So if I'm to replace this P, it's going to be, 36 root 2 equal to 36, 36 root 2. So this is what I'm supposed to get. So it means that P is equal to 36. That is the answer that we are expecting. So that is how you're supposed to find the first one. Let's get the second question. That is 1 A I I. And we have to find the factors of P. Now we have seen that P is equal to 36 in the first question. In the first question, that is 1 AI. We're going to look for the factors of 36. So the factors of a number are the numbers that when you multiply, you get this number. So when you take 1, you can multiply by 36 to get 36. So 1 and 36, they are factors of 36. You can take 2. Now any number that ends with an even number means that 2 can go into it. So 2 times what will give you 36. That's going to be 18. So 18 is part of the the factors. We didn't add it to the previous one, so make sure you correct it. That is 18. Now we can also think of 3. 3 times what will give you 36. That's going to be 12. What about 4? Yeah, 4 times 9. That also give you 36. The next one, 6, and that's going to be 6 times 6. It will give you 36. But you see, 6 is repeating itself, so we just write one of them. So don't go and write 6 and another 6 here. No, just one of them. So these are the factors of 36. And the last one, that is 1A I. We find the sum of the factors of these. So that's going to be 1 plus 2 plus 3 plus 4 plus 6 plus 9 plus 12 plus 18 plus 36. And you're going to get 91. You can add it to verify. So that is the answer. Let's get the second question. That is 1B. So let me work that one here. We have 1B. And the question is 2 points on a certain straight line are, the point A with coordinate 5, 7. So we have point A with coordinate 5, 7. And that of B with coordinates, 11, 4. We have to work out the slope or the gradient of the line. The slope is the same as the gradient. So how do we do that? This is a simple question. We know that gradient, which is denoted by the letter M, the small letter M, is equal to, change in Y over change in X. This formula. And now when we say change in Y, it means the difference in the Y values. Change in X means the difference in the X values. The difference means we're going to get, Y2 minus Y1 over X2 minus X1. So that is what you have to know. Now the question is, how do we get this Y1, Y2, X1, X2? They are just here. This is what you're supposed to know. Whenever you have a point like this, the number that you see here, we call them the coordinates. Now, the first number that you see, we call it the S coordinates. This one is going to be the Y coordinates. The same thing applies to this point. The first number is the S coordinates, and this is going to be the Y coordinates. Now, let's see this confusion. When I say give me X coordinates, how? That's going to be confusing, right? You will probably give me 11 or 5 because they are all S coordinates. So to avoid this confusion, we just try to give them specific names. So we decide to give this one X1 because they come first, and we give this one to Y1 because that's from the first point. We come to the second point, second, so we give them 2. So this is going to be S2, and this one becomes Y2. So that is why we give them these names. We can decide to give them different names, and that is correct. So we are using these names just to avoid confusion. So now we can get Y2, Y1, S2, Y1, S1. Let's do the substitutions. Y2 from the question is 4. So that's going to be 4 minus because the formula says we have to subtract, and Y1 is 7. So minus 7. Now out of, S2 is 11 here. So we have 11 minus 5. That is X1 here. Now let's do the subtraction. 4 minus 7, that's going to be like 3 on, 6. 11 minus 5 is 6. We are not done. We can simplify. 3 here 1, 3 here 2. So that's going to be negative 1 on 2 because of this negative sign. So that's the final answer. So that's a negative gradient. It's normal. to get negative gradient. So we are done with this one. Come to the second question. We have to evaluate, the root of 125 minus the root of 180 plus the root of 45. So that's the set. And how do we do, or how do we simplify such an expression? Now, we are going to break these numbers down, 125, 180, 45, down to the simplest form that we can't even do anything about it again. But you should know that always try to look for two numbers that when you multiply, you get these numbers. And if you're fortunate to get a perfect square in the numbers, then that'll be very, very good for you to make the work easier. If you don't get a perfect square, no problem, we can still do it. So now let's move on. We have the root of 125. So you just ask yourself, which two numbers are you going to multiply to get 125? If you don't know, you're not supposed to use a calculator. So you can use try and error. You just look for just two numbers that when you multiply, you get 125. And let me give you this trick. Any number that ends with 5, it means 5 can go into it. So it means we can multiply 5 by a certain number to get 125. And the number is going to be 25. So if you don't know, you can check it. So let's break this one down. So this is going to be the root of 25 times the root of 5. And that will give you this one. You get it? Now, come to this one, minus 180, the root of 180. Let's take 18. Even before we think of this 0. 2 times 9 will give you, 18. So it means 2 times 90 will give you 180. So let's get that one too here. The root of 2 times the root of 90. Good. We come to the last one, and this is very, very simple. The root of 9 times the root of 5. So these are the numbers that when you multiply, you get these numbers. Now let's simplify our expression. The root of 25 is a perfect square. Do you know perfect squares? Whenever you multiply a number by itself, for example, 5 by 5 will give you 25. This 25 is a perfect square. 3 by 3 will give you 9. 9 is a perfect square. 4 by 4 will give you 16. 16 is a perfect square. So whenever you multiply a number by itself, the answer that you get is a perfect square. So it means that 5 is a perfect square. The root of 25, the root, so it means that 25 is a perfect square. And the root of 25 is going to be 5. So we have 5 here. Remember, it is multiplying the root of 5. So you have times the root of 5 minus. Let's come to this guy, the root of 2. Wow, you can't get any number that, the only number is going to be 1. 1 times 2 will give you 2. So it means we can simplify the root of 2 again. We just have to write the same, the root of 2. Now let's come to 90. We can think of, 9 times the root of 10. We can still simplify 90, and that is what we are getting. We come to this one. The root of 9 is going to be 3 times the root of 5. Good. At this point, we can simplify these guys. 5 times the root of 5 is going to be 5 root 5. This is where the problem is. We have to simplify this guy. Now, minus the root of 2 times. This one is very, very simple. The root of 9 is going to be 3. Good. Now we come to the root of 10. Well, we have to simplify the root of 10 again. And which two numbers are we going to multiply? Obviously, the root of 2 times the root of 5. That will give you 10. So plus, let's multiply these guys. 3 by the root of 5, what are we going to get? Tell me. And that's going to be 3 root 5. Good. So you see that we don't have a problem with this and that. The problem is with these guys. And we've got to multiply them, or we have to simplify them. You see, you have to multiply them. Have you seen the multiplication sign? You have to multiply them. So let me maintain these guys. They are just waiting for the middle ones. Let's see something. I'm going to multiply the root of 2 by this one. It's not that I am grouping like terms. No. But I want you to see something here. Whenever you multiply a set by itself, for example, the root of 2 by itself, which is the same as the root of 2, we're going to get 2. I'm going to show you the reason. The same thing applies to this one. The root of 3 by the root of 3, we're going to get 3 here. The root of 4 by the root of 4, we're going to get 4. So what is happening? We just take the number in a radical sign. And how do we get that? This is what happens. For example, when you multiply the root of x by the root of x, you're going to get a big root of x squared. That is, x times x will give you x squared. And this square can cancel the square root. So you are left with x. You see? So the same thing happens to, the root of 2 times the root of 2. You're going to get a big root of 2. 2 times 2 can be written as 2 squared. Good. And this square can cancel the square root. And we are left with 2. So that is why we have this. So that means that I can, group these guys. So I'm going to get this one, minus the root of 2 times this guy, the root of 2, and it is left with 3 times the root of 5. So we have 3 times the root of 5. Remember, we have this guy too waiting for us. So plus 3 root 5. So at this point, let's simplify it. So like I just told you, the root of 2 times the root of 2 is going to be 2. But remember, we have a negative sign. So that's going to be neg 2. We are left with these two guys. 3 times the root of 5. That's going to be, times 3 root 5 plus 3 root 5. This one. Now, we can still simplify this. So we're going to get 5 root 5. Neg 2 times 3, that's going to be neg 6 root 5 plus 3 root 5. Wow. So at this point, we can see that all the radicands are the same. That will make the work easier. To be able to add or subtract sets, make sure the radicands are the same. If the radicals are not the same, you can subtract. So when I give you, let's say, the root of, 4 root, let's say 5, let me say 6 minus, 2, let's say 3. We can't subtract this one, this one from this one. No, because the radicals are not the same. But here we are fortunate, they are the same. So what am I going to do? I'm going to add or subtract the coefficient. These are the coefficients. These are the coefficients. So I'm going to add or subtract the coefficient, and then I'll just take one of the sets. So let's do that. So we have 5 minus 6 plus 3. 5 minus 6 plus 3. Then I'll just take one of the sets, which is the root of 5. 5 minus 6, that's going to be neg 1. So let me just write it here for you. Neg 1. Now plus 3. That will give you 2. So it means the whole of this is going to be 2. And the root of 5. So that's the final answer. So when you simplify or when you evaluate this expression, you're going to get 2 root 5. Very, very interesting.